Hi, welcome to part 5 of the Accuphase P-300 restoration. In this video I'm going to be focusing on the final service bulletin mod that I want to do, which is related to the main filter capacitors. I'll also take a look at the meter calibration, DC offset bias, it's basically all the amplifier adjustments, and finish off with maybe experimenting with some different LEDs to replace the incandescent panel lamps. So on the main filter capacitors, these are the big capacitors in the power supply. They're big gray units on the front of the unit, which we'll see in a minute. Originally, this unit was designed to operate on 117 volts AC, and that's evident in the voltage selector on the back, which, you know, you can choose a couple different world voltages, and the US voltage is 117. Nowadays, mains voltages are much higher than that. 120 is probably the average. In New York City, I'm usually between 123 to 127, depending on the time of year. So if you just plug this amplifier in and operate on modern mains voltages, these main filter capacitors are going to get stressed. So the ones that are in my unit are spec'd at 63 volts DC operating voltage. Let's just do a demonstration here. So I've got the Variac set to 117, so simulating the old mains voltages. If we look at the meter, I'm about 61 volts, which is well within the working voltage tolerance of the cap. There's not a lot of headroom, but it is technically safe. If let me drop down a little bit with the load. 117, yeah, so we're about 61 volts. If I raise this up to 120, which is common in most parts of the United States, we're right on the edge of that capacitor tolerance. If I go to where I'm going to be operating at in New York City, around 123, we're already exceeding the working voltage specification of the capacitor. So in a normal situation on a vintage piece, if the capacitor is rated properly and has enough headroom, and I test it for leakage, and it has no physical electrolyte leaking out of it, I a lot of times will leave those big capacitors in because they're hard to source in the right dimensions. But in this case, it's actually kind of a design flaw because this cap is really not safe to operate. So we're going to put an 80 volt unit in here and go from there. So that's what we'll get into next. I'll flip this down. We'll take a look at those caps and the replacement parts that I've got. These are the two filter capacitors that we're looking to replace as part of this modification. Normally, when I would look for a capacitor replacement like this, I would go to Mauser or DigiKey and just filter by the diameter of the capacitor, the height range that I need, and then give a range of capacitances from the value that's in the unit, maybe plus 20-30%, just so that I can get a range of different capacitors to choose from and pick the one that's best for the application. The problem here is this capacitor is not a standard size. The diameter is about 76 millimeters, but the height is not common. The common capacitor for this form factor is a few millimeters higher than this, and it will not fit in the chassis. So with the top cover on this unit, the capacitors are right up against the cover. So if we go higher than the original part, it's either going to bow the cover or it won't fit on at all. This unit can be ran without the top cover, and it actually looks pretty nice. There's a bunch of trim pieces that we'll eventually see once I get this fully assembled. So it actually looks kind of cool with the top cover off, kind of Macintosh style. But I really want this unit to be cosmetically sound. So I searched for probably 2 weeks for replacements for these capacitors, and I kind of went outside of the box. I looked for companies that were selling new old stock parts. They were liquidators basically, and I called a few of them, gave them 5 or 10 different capacitors that would work, and no one had anything in stock for me. So we had to make a little bit of a compromise. So this is what I ended up going with. This is a Nichicon KG series super through capacitor, but you'll notice I had to go way down in the capacitance value. This is a compromise that just has to be done in my case. I can't source the correct part, but this Nichicon is the correct height and the correct diameter. So this is going to take the capacitance of the power supply down a bit, which may affect low frequency response, but in this case we are going with an audio grade main filter capacitor. So I'm hoping that that we don't have any negative performance things, I doubt it's anything I could measure, and without having a reference of this thing listening, I don't know if I'd be able to do a before and after. But if I ever work on another one of these, I'm going to try to compare the 22,000 to a 40,000 and see if there's any sort of sonic difference. So that's what I'm going to be doing next, is getting these capacitors removed and installing the Nichicon capacitors in their place. The original caps are now removed, and look at the mess that we've got underneath here. So this capacitor here, so this one has obviously been physically leaking, and then this one here on the negative rail doesn't show as many signs, but it does have a bulged section here. So I'm really glad that I'm replacing this. Even if the capacitance value is lower, I think we're going to be much better off with these. And look at how nice that's going to look in the chassis. So we'll get these guys installed, and we'll see how it looks when it's done. Okay, the new Nichicon capacitors are installed, and they look awesome. I'm really happy with them. Here's the top cover. Perfect fit. And to give you an idea what this looks like with some of the additional trim pieces installed. Eventually those will go on there, and then there's one for the front. So this thing looks really slick with the cover off, and it's going to look even better with these black and gold caps rather than the original gray ones. So really happy with how that came out. So I'm set up here to set the final DC offset and bias for these amplifier stages. I've had the unit on full power, no variac, warming up for about 20 minutes. I've got measurements here for the bias for both channels, and then I'm measuring DC offset on one channel up on that meter there. So I had to piece this procedure together out of some snips from various people posting parts from the manual and just searching around. It seems to be that the level that we want to be at here across these test points is 55 millivolts. I'm going to start with the bias adjustment on both. So I'm looking for 55 millivolts. And this does settle off, so you have to make minor adjustments and then wait for it to come back. So I'm looking for 55 millivolts on both sides. That's just settling in there. So right now I'm set up to measure DC offset on this channel here. So I just need to adjust this one now that the bias is set. And I'm just looking for as close to 0 volts as possible. That's what I'm looking for. So it's looks like it's hovering right around that 0 point, going between plus and minus. So that's looking really good there. Go on to the other channel. That's probably about it right there. See, my bias is now, actually it looks like it's pretty stable right around that 55. So I think this is good. So that's bias and DC offset. And now we're going to move on to calibrating the meters. This is the meter board here. So there's basically an array of resistors that allows different levels. So we have 0 dB, -10, and -20. I've replaced these trimmers here so that we can get a nice accurate adjustment, and there's also just a couple electrolytic caps back there. Okay, to do this meter calibration, the setup that I've got going on is the outputs are both plugged into my 8 ohm dummy load, left and right channel, and then each one of these meters is hooked up across those outputs measuring AC volts. So we're going to feed a sine wave in, have the amplifier producing 150 watts, which is rated power, into 8 ohms. 0 dB is selected. So when we're at that level, we're aiming for a 0 indication on the needle. So I'm looking for 34.6 volts is equal to 150 watts into 8 ohms. So I'm just going to bump down my signal generator, 34.56.
34.7. That's close enough for what we're doing here. We can see this one's just a little bit off, so I just come into this adjustment. Right into 0. It's the dummy load fan kicking in. Right there. Okay. So now we'll turn off the generator, and for the next setting, 15 watts is about 10.95 volts. So I'm going to bring down the signal generator. Right around there, and you can see it's accurately showing negative 10 dB. If I change the scale, we should be at 0 here. Pretty darn close. And then the final check would be at 1.5 watts, which is 1.5 watts at negative 20 dB, so that's 3.46 volts. So let's take this down again. Come on. 3.46, 3.47. Again, showing negative 10 dB because we're on that scale. If I go back to here, it should be around negative 20 dB, and we should be full scale. Perfect, so these meters are tracking beautifully. And that's it for the meter adjustment. So when I'm listening to music, I'll probably have this on the negative 20 dB scale just so I can see the meters moving. But this is nice that they're that accurate. This is a really nice meter circuit. The front panel LEDs operate on 8 volts DC. It's 16 volt with 2 of them in series, so this was a really good candidate for LED replacement. I didn't know which color would look best with these meters, so I ordered a little bit of everything, and I was just having a little bit of fun earlier. This is never something that I would actually install, but it's kind of cool that you can do a gradient if you want it on the meters. I'm probably going to be doing either this blue that'll make it look kind of like a Macintosh piece, cool white, which really brings out kind of the metal texture in the back of the meter, or warm white, which is going to simulate the original incandescent. So I'm going to put the front cover back on and some of the trim plates, and then look at it from the front and see which color is going to work best. Got the front panel back on. Knobs are installed. Everything is looking really nice. This is with the multicolor LED. Again, I don't think I'd ever run it like this, but it's kind of cool. This one's almost red, white, and blue, so you can kind of see what it looks like from the front now. I'm going to roll through 2 or 3 other options. I'd like to hear what you guys think in the comments, which ones you like the best. So I'm going to end the video after that. Thanks again for stopping by the channel. This will conclude the P-300 restoration. I will be doing another one of my typical restoration review videos on this unit eventually, but this will wrap up the segment on the actual restoration at the bench. So again, thank you so much for stopping by. Subscribe if you like this content, and stick around. See you next time.